Alrighty, in this video, we're going to be talking about confidence intervals and sample size for a proportion. So our fourth objective is to find the confidence interval for a recent USA Today snapshot stated that the had someone walk into them is 36%. 36% represents a proportion of cell phone users. The parameters in the is the proportion of cell phone users who had someone walk into them. The sample size was 738, and the proportions represents the part of a whole group and can be expressed as a fraction, decimal, or percentage, or represent a probability. For instance, if a cell phone user is randomly selected, the probability that they have had someone walk into them is 0.36. That's just an example of proportion. So as we continue to kind of look at some definitions and vocabulary, symbols used in proportion notation, lowercase p will represent the population proportion. What we call p hat basically has like looks like a inequality symbol right above the p, represents the sample proportion. So for a sample proportion, you can have p hat is equal to whatever the x is, which is the number of samples units that possess the characteristics of interest, and then the n would represent the sample. So for instance, if I have 36 people out of 100, I would do 36 out of 100. Q hat is basically the opposite. It's basically represents portion of the event not. So you can write it as 1 minus p hat, or if you're just trying to find q hat, you could do n minus x to find out what portion did not do the event that you thought happened, divided by the sample size. Let's look at an example here. So as we look at example 6, we're going to find the sample proportion and its complement. Remember, complement's basically 1 minus whatever the event is. So if we have n equals 80, basically means that we have a sample of 80, and x equals 45, meaning 45 people do the event that we're looking at. And we're just going to simply find p hat, q hat. So to find the p hat, we would just do the amount of people doing the event divided by the total sample. So in this case, that'd be 45 divided by 80, which would just be 0.5625. If I then wanted Q hat or the complement, or trying to find out what is the percentage or proportion of the event not happening, I can do 1 minus p hat, which in this case would be 1 minus 0.5625, which would equal 0.43. There we go. Sorry, my speaker went out. So 0.4375. Or I could have done 80 minus 45, got 35, and done 35 divided by 80 and got the same result. All right. All right, so let's talk about confidence intervals in proportions. So the assumption that must be made to find a confidence interval for a population proportion are the samples must be a random sample, and the conditions for a binomial experiment must be met, meaning there's only two things that can happen: the event you're looking for, or the event doesn't happen. So for instance, if I'm rolling a die, it has 6 options, but if I'm only looking at what's the probability of landing on a 2, then it's either a 2 or it's not a 2. It's got to get down to just 2 options. So here we talk about the margin of error for proportions is kind of similar to what we've seen in the regular confidence intervals. But the margin of error would be the z-score at alpha divided by 2, still looking at the same parameters there, but this time multiplied by the square root of p hat times q hat. Rather than the population standard deviation, you would do p hat divided by q hat, and you're still dividing by n, which is the sample space. Do note two things. You must make sure that n times p hat is greater than or equal to 5, and n times q hat is greater than or equal to 5. If this doesn't happen, we cannot use this math. The formula for a specific confidence interval for proportions, again, very similar to with the population standard deviation known or unknown. The only difference is that p hat times q hat. And then instead of a sample mean, you're doing the population or proportion mean, or I guess p hat would be the proportion that actually happens, minus this kind of same setup to kind of figure out if this is my sample that took out the entire population's probability would be somewhere in between these two things. So let's look at example 7. All right, we're going to travel to outer space. So a CBS News New York Times poll found that 329 out of 763 randomly selected adults said they would travel to outer space in their lifetime given the chance. Estimate the true proportion of adults who would like to travel to outer space with 92% confidence. It's one of those weird ones. Remember, we have all memorized for 90, 95, and 99, but we'll be doing the math for 92. So here we go. So this kind of does it for us, but you can kind of see the step by step. So our X would be 329. These are the ones that do want to go out in space. My N is 763. That was my total population that I sampled. So therefore, my p hat would just be X divided by N. So that's 329 divided by 763, which gives me a 0.4312. So 43.12% of my sample would go out in space. So my Q hat would then be 1 minus that, which would then give me 0.5688. So that means that 56.88% don't want to go to outer space. So then we would look up the z half divided by 2 for alpha. We can see that we would do 1 minus 0.92 and would get 0.08. Then we divide that by 2 and we get 0.04. If we then go to Appendix A, Table E at 0.04, we will find it at negative, but we know that this can be plus or minus 1.75. So for 92%, I don't expect y'all to memorize this one, but be able to use the Appendix A to find it. Once we have the correct z-score to get our margin of error, we would do z-score times the square root of p hat, or this is p hat, times the q hat divided by n. Once we get that, we see that we get 0.0314. You then take that and you add it and subtract it from the p hat. So in this case, I would take the 0.4312, and I would plus or minus the 0.0314. So you can see this is what I get. So my estimate for the probability of the all adults that want to go into space would be between 39.98% and 46.26% with the data that I've obtained. All right, let's do another one, but this time we will do it, but then that gives you the process nicely typed for you. So in example 8, we're going to look at a cell phone poll. So in a poll of 738 cell phone users, 266 stated that they had been walked by someone using their cell phone. We're going to estimate the true proportion of cell phone users who have had someone walk into them with a 95% confidence. All right, here we go. So we start off by looking for our X. In this case, that's 266. followed by our N, which we can see is 738. Then we would look for our P hat, which remember would just be 266 divided by 738. We type that in the calculator, we actually get 0.3604. Then we would do Q hat, which would just be 1 minus 0.3604, which then gives us 0.6396. So now that we have our X, our N, our P hat, and our Q hat, we just need to find out our alpha divided by 2. So we actually know this one at 95%, or you should at this point. It's going to be that plus or minus 1.96. Now, if you forgot, remember you can do 1 minus 0.95 and get 0.05. Divide that by 2 and get 0.025. Then use the Appendix A Table E to look for this result, and you would find it right here. All right, now that we have our Z-score, we can then find our margin of error. So this would be, I'm just going to start off with a positive. So 1.96 times the square root of P hat, which in this case would be 0.3604, times my Q hat, which would be 0.6396. Divided by my N, which is 738. When I do that, I actually get 0.0346. So then I take that result and I'm going to add and subtract it from my P hat. So this would be 0.3604 minus 0.0346. And then I would take 0.3604 plus 0.0346. And when I do that, I end up getting 0.3258 and 0.395. So I can see that I think my true proportion of people that run has reported that someone has run into them using their cell phone would be between 32.58% and 39.5% with a 95 confidence that any sample taken would fall in between this. All righty. So let's look into Objective 5. Objective 5 just says determine the minimum sample size for finding a confidence interval for a proportion. So we did this with standard deviation, population standard deviation known or unknown. Now we're just going to do it with proportion as well. So sample size, to find the sample size needed to determine a confidence interval about a proportion, we solved for the margin of error formula for the sample size. So we did this earlier, but when we work this out, you would divide by the z-score, square both sides, multiply both sides by n, then divide by the z-score squared, and then you end up getting something like this. So you get the p hat times q hat times z alpha divided by 2 divided by e squared. In this statistics course, I would never expect you to be able to use literal equations in algebra to get it to this point. I just expect you to be able to use this formula to find out what the sample size needs to be. Again, remember, we're always going to round up to the nearest whole number. So even if you get like 103.3, that's 104 people. You need to always round up. You need that part of a person, so you got to go up to the next person. All right, so let's look at example 9. We're going to be talking about widows. So a recent study indicated that 29% of the 100 women over the age of 55 in the study were widows. How large a sample is needed to be 95% confident that the estimate is within 0.03 of the true proportion of women over age 55 who are widows? All right, so what we do, it says 29% of 100 women. So we need to figure out what is 29% of 100. So all you got to do mathematically is do 100 times 0.29 and you get 29. So there's 29 women who out of over the age of 55 who are widows. All right, then we take that and we just basically, so we got the X. We just got to determine the P hat the Q hat, and then we should, oh, and the Z score. Okay, so we got the X. So then to do the P hat, this would be 29 people. That's your X. Divided by your N, so that's 100. It does come out to 0.29. So then your Q hat would just be 1 minus 0.29, which would just be 0.71. And then from there, we got to find the Z hat. So this again, the Z alpha divided by 2 at 95% confidence should be plus or minus 1.96. Once we have our Z score, then we can just, oh, it does say it gave us our error too, because normally we have to go look for that. So our error is actually at 0.03. So now that we have everything we need, now we can plug it into that formula. So remember, it was N equals P hat times Q hat times Z alpha divided by 2 over E squared. So in this case, this will be 0.29 times 0.71 times 1.96. And because it's squared, don't worry about the positive or negative. The result will still be the same. Divided by 0.03 squared. And when you do that, you get 878.87, which again, we always have to round up. So we would say 879 people that need to be in our sample for this to work. There you go. All right. So let's look at another one. Oh, it looks like I did most of the work for you. You just had to fill it in. Well, that's nice. This one does not, so let's do it together. So again, we're going to be talking about diet habits. So it says a federal report indicated that 27% of children ages 2 to 5 years had a good diet. How large of a sample is needed to estimate the true proportion of children 2 to 5 with good diets with 2%? So it should be within 2% because this is going to be your error. With 98% confidence. So, okay, so we got 2 to 5, 27% of 2 to 5-year-olds. All right, let's do it. All right, so I can't determine my X because I don't have an amount of people in this one, but I can determine my P hat, which would be 27%. So that's going to be 0.27. And in this case, then Q hat would just be 1 minus 0.27, which will come out to 0.73. My E would be 0.02. And then for my Z score, this one I'll have to kind of do a little bit. So we'll do this. This will imply that we need to do 1 minus 0.98, which gives us 0.02. Divide that by 2, we get 0.01. So then we go to our Appendix A, Table E. We would determine that the Z score for 0.01 would be at plus or minus 2.33. And again, all I was doing was looking at the table that's in your book. Again, make sure you are tagging that so that you're able to easily get to it because you're going to be using it a lot. All right, now that we have everything, then we can go and find our N. So in this case, that's 0.27 times 0.73 times 2.33. Again, don't stress about the plus or minus. Divide it by the error, which is 0.02 squared. And this right here will come out to 2,675.09. Again, you must always round up, even though this tells you to round down. This will be 2,676. If you need 0.09 of a person, then you're going to need the next person. So this is your sample size for to find the true proportion. You would need to at least survey 2,676 children between the ages of 2 to 5. With a 2% error, and have a 98% confidence. All right, so I think that's about it for this one. All right, so again, if you have any questions or need more examples, please reach out. Until the next video.